In this video, we're going to talk about exponential equations, and as the name implies, these are equations that have exponents. And this is the classic format of these equations, the most simple format, y equals b to the x, where b is referred to as the base. And here's a real-world example where y equals 2 to the x. Now these exponential equations can become a little bit more involved when we have what are called transformations. And in that scenario, they have this format where the graph is translated in the vertical direction with the plus k and in the horizontal direction with an h value. And the graph is also stretched or compressed based on what that coefficient a is equal to. So for example, you may see this as an example of an exponential equation. And in this video, I'm going to show you how to graph both the basic and the more complex versions of exponential equations. Now, it's important to note that the base of these exponential equations have restrictions. Namely, the base cannot be negative, it can't be 0, and it can't be 1. So this example of y equals 2 to the x is a legal exponential equation because this base, namely 2, is positive, meaning it's greater than 0, and it's not equal to 1, and it's not equal to 0. Here's a graphic representation. The red is not allowed. Can't be negative, can't be 0, can't be 1. That's why these are open circles. However, the base can be between 0 and 1, and it can be greater than 1. If it's 0 then 1, if it's between 0 and 1, by definition, it's a fraction. So we're talking about y equals 1/2 to the x, or y equals 1/3 to the x. Sorry. Again, the base is between 0 and 1. It is not negative. That is a legal exponent. And it turns out, exponential equation, it turns out whenever you have a fraction as the base, these are decay problems. And that has certain implications of the graph, which we'll talk about it. When the graph is greater than 1, like the example we've been talking about, you have a growth problem, or a growth equation. Now these exponential equations have a unique look to them. Specifically, they all include what's called a horizontal asymptote. An asymptote is in this case, horizontal line. It can also be vertical. And it's a line that the graph approaches but never reaches. Notice, on the left, you have a decay problem because the base is going to be a fraction between 0 and 1. And in a decay problem, the graph always approaches the asymptote. It can do it from below as well, but it always approaches the asymptote. On the right, you have a growth problem because the base is greater than 1. And when you have a growth problem, the graph as you move left to right moves away from the asymptote. Again, you can have it below the x-axis, moving away from the asymptote, but a growth equation will always move away from the asymptote. Okay, so let's quickly review. These above are all legal exponential functions. The bases are positive, and they are not equal to 1 and not equal to 0. Compare and contrast to what's listed below. Here, the exponent is, the x variable is not in the exponent. This is a quadratic function that you're familiar with. G of x, it is not an exponential function because the base equals 1. Here, h of x, negative 1. Here, you have x both in the exponent as well in the base, not a legal exponential equation. Okay, so let's graph some of these. And let's start with the equation we've been talking about, y equals 2 to the x. So first I want to show you the intuition, and then we're going to pick x values, compute the y value, and then plot the points. So the intuition when I look at this is that this is a growth problem. First I ask myself, is it legal? Answer yes, because you have a positive base, not equal to 1 and not equal to 0. It is a whole number greater than 1, therefore this will be a growth problem. This way, therefore it's going to move away from the horizontal asymptote. I'm going to label that HA. Now, very important, where is the horizontal asymptote? To answer that question, I'm going to go ahead and I'm going to write the more detailed version of this equation using hidden ones and zeros. So this equation could also be written like this. These are the same two equations. I plugged in the hidden 1 and hidden zeros. This is your horizontal asymptote. So in this case, our horizontal asymptote is going to be y equals 0. And where is y equals 0? It's none other than the x-axis. Okay, this green line, the y values on this green line is always going to be equal to 0. So this is our HA, or the horizontal asymptote. And because this is a growth function, I know that my graph is going to be moving away from this horizontal asymptote as we move from left to right. Now we're going to plot points. When you pick your x values that you're going to plug in to your equation to determine the y values, that is strategic. I want to pick x values that make my math easy. So in this case, I'm going to set x equal to 0 and x equal to 1. Whatever the construct is up here, you set that equal to 0 and equal to 1. Recall, in this particular case, there is a hidden 0 here. That is not always the case. So in this case, I'm going to set x plus 0 equal to 0 and x plus 0 equal to 1. This is going to give me x equal to 0, x equal to 1, and those are the numbers I'm going to plug in. But what if you had this, for example? What if you had x minus 2 up here? Then what you would do to make your math easier is you set this entire construct, x minus 2 equal to 0, x minus 2 equal to 1. You solve for x, you get x equals positive 2 and x equals positive 3. Then these are the numbers that you would plug in your table and work with in order to make your math easier. Okay, but let's stick to this particular example and let's use x equals 0 and x equals 1. When you plug x into that original equation of 0, you're going to get y equals 2 to the 0, which equals 1, and y equals 2 to the 1, which equals 2. So these are the points you're going to plug in, 0, comma 1, and 1, comma 2. So let's do that. 0, comma 1, 1, comma 2. As we move from left to right, we connect the dots, and that is your graph. As predicted, as you move from left to right, you're moving away from the horizontal asymptote. Let's look at this one. Here, we remember that in exponents, if we have a negative exponent, we can flip what's in the parentheses and change the sign of the exponent. So this becomes 1/2 to the positive x. So that's the function I'm going to work with. These are equivalent functions. Now let's do the intuition. Is our base legal? Answer yes. This is positive. It's not equal to 1. It's not equal to 0. But we notice it's a fraction. Therefore, this is a decay problem. That immediately tells me that the graph, as we move from left to right, is going to go toward the horizontal asymptote. Where is our horizontal asymptote? Well, there's a hidden plus 0 there. Our horizontal asymptote is going to be the x-axis, and we're going to label that as the HA, and y equals 0. We are now going to pick our points, or I should say plot our points. We're going to choose x equals 0 and x equals 1. And when we do that, we get x equals 1 and, I'm sorry, y equals 1 and y equals 1/2. Our points are going to be 0, 1 and 1, 1/2. So as we move from left to right, our graph is indeed going to approach the horizontal asymptote. Next one. This is a deceivingly complex problem because at first glance you might say that's not a legal exponential equation. But it turns out PEMDAS applies here, meaning the exponent takes precedence over multiplication. And what we have here is really multiplication of an exponent. So this takes precedence, and this is legal. This would not be legal. Excuse me. This would not be a legal exponential equation. Those parentheses are different than what we see up here. These are two different scenarios. This is illegal, and the one up top is indeed legal. Okay, so now that we established that this is a legal exponential equation, let's do some intuition. It's going to be a growth problem, which means it's going to go away from the horizontal asymptote. What is our horizontal asymptote? It's going to be at y equals 0. Let's draw it in. Let's label it HA, y equals 0. This negative sign out front is going to result in flipping the graph over the horizontal asymptote, which in this case is the x-axis. Let's plug in our x values. We're going to use 0 and 1. And when we do that, we get y equals -1, y equals -2. So we plot 0, -1, 1, -2. Our graph, as we move from left to right, as we predicted, because it's a growth problem, is going to be moving away from the horizontal asymptote. Okay, let's do the next one. Okay, here's a little bit more complicated. This involves transformations. First thing I do, is this a legal exponential equation? Answer yes, because the 2 is positive. The 2 is greater than 1. It's going to be a growth problem, meaning it's going to move away from the horizontal asymptote. Where is our horizontal asymptote? It's at the point where y equals -1. Let's draw that in. Let's label that as the HA, y equals -1. So I know that my graph, as I move from left to right, is going to be moving away from this horizontal asymptote. We pick our points. Okay. Here, we're going to be strategic. We're going to take this entire construct, and we're going to set it equal to 0, and we're going to set it equal to 1. When we set it equal to 0, we get x equals -2. And we set it equal to 1, we get x equals -1. These are the x values we're going to work with. When we plug in x equals -2, we get y equals 0. When we plug in x equals -1, we get y equals 1. These are the points we are going to plot, knowing that as we move from left to right, we expect to be going away from the horizontal asymptote. First point is -2, 0. Second point is -1, 1. Connect the dots. There is our graph. Next one. Again, involving transformations. Let's do the intuition. Is it legal? Yes. This negative is not in the parentheses, therefore it is legal. I have a fraction. I'm going to have a decay problem. I know that eventually this graph is going to head towards that horizontal asymptote, which is at y equals +2. Let's label it. Let's plot our points. I'm going to choose x values that make my math easy. The first one is x plus 2 equals 0, and then x plus 2 equals 1. When x plus 2 equals 0, x equals minus 2. When x plus 2 equals 1, x equals minus 1. When I do my math, I'm going to get negative 1 for y and positive 1/2 for y here. I'm now going to plot my points. My points are going to be negative 2, negative 1, negative 1, positive half. As I predicted, my graph, because it's a decay problem, is going to approach the horizontal asymptote as I move from left to right. Next one. What's my intuition? A, is it legal? Answer, yes. I have a decay problem. This graph is going to head towards my horizontal asymptote. What is my horizontal asymptote? It is at y equals positive 1. I'm going to draw it in, and I'm going to label it. Next, I don't see a negative sign, so this is not going to be flipped. I take my exponent, I make my math easier by setting it equal to 0 and equal to 1. When I do that, I get x equals positive 3 and x equals positive 4. When I plug them into my function, when I plug in x equals 3, I get y equals 5. When I plug in x equals 4, I get y equals 2. Now I plot my points. 3, 5, and then 4, 2 is here. So this is going to come down relatively steeply and hug my asymptote. And the reason this is a little steeper than the other graphs is that 4. That makes things steeper. Next one. Is this legal? Yes. This is decay. It's going to be coming towards my horizontal asymptote. Here's my horizontal asymptote. Let's label it. I know as I move left to right, I'm going to be coming towards, and the other thing I predict is that this 1/3 is going to make things a little bit flatter. Here we have a relatively easy exponent. We're going to set x equal to 0 and x equal to 1. When we do that, we get 4/3 when x equals 0. And when x equals 1, we get 7/6. Now when I graph, I like to convert this to mixed numbers because it gives me a sense of where I am. And I even like to have it in the same denominator. So that lets me know that this y value is going to be slightly north or slightly higher than that value. Okay, so the first one is going to be 0 and 1/3, something like here. And then the next one is going to be 1 comma 1/6. So it's a little bit closer to the horizontal asymptote. I should have used a different scale there. But that is your graph. Again, a decay problem heading towards the asymptote. Totally fits our intuition. Okay, I believe this is our last problem. It's legal. It's going to be a growth. It's going to be moving away from this horizontal asymptote. Here it is. HA, y equals +1. We set this to 0 and equal to 1. When we do that, we get x equal to 2 and x equals to 3. These are the numbers we're going to plug in to find our y. They will make our math easier. When we do that,
We get 1 and 1/4 here and 1 and 1/2 here. Again, we predict we're going to be moving away from the horizontal asymptote. Here's our first point, 2 comma 1 and 1/4, and then 3 comma 1 and 1/2, which is bigger, higher, and that's our graph.